Today we're going to continue with greatest common factors, but we're going to start factoring that out, and you'll learn what that means in a second. First, just a quick reminder of something we did about a week ago. When you multiply a monomial times another polynomial, you distribute. I have to multiply the 6 times the x and the 6 times the 8, which gives me an answer of 6x plus 48. Here, if I multiply this 8x, do 8x times x squared is 8x cubed. This x to the first is adding 1 to each of the exponents inside the parentheses. And then I have 8 times 4 is 32. X times x is x squared. This is multiplying or distributing. The distributive property says if you take something in the form a times the sum of b plus c, you have to when you multiply, you have to distribute the a over the b and the c. So it becomes a times b plus a times c. And we've seen this several times this year. What we're going to do today is talk about factoring. If I have this expression, a times b plus a times c, I can go back in the other direction if I factor and get this form with the a outside of the parentheses. You factor out the a, and b plus c is what is left. The factored form is what's on the left, the a times b plus c. The expanded form is what's on the right, ab plus ac. What we're doing today is called factoring using the GCF. In order to do this, the first thing you have to do is find the greatest common factor of all the terms. That's what you worked on last Wednesday and Thursday. Once you find the GCF, you divide each of the terms by the GCF, and then the factored form is the product of the GCF and the quotient. For example, I want to factor 4x plus 24. I need to find the GCF of 4x and 24. You can make a factor tree, and for some of these, you may find that the numbers are small enough that you can find the GCF right away. For example, if the smaller number 4 is a factor of 24, then it has to be the biggest number that goes into both of them. 4 does divide into 24, so it is the GCF. We'll do a factor tree with some bigger numbers in a minute. Here, if my GCF is 4, and notice there's no variable with the 24, so there is no variable in the greatest common factor. My greatest common factor is 4. I'm going to divide each of the terms by 4, and the factored form is the product of the GCF and that quotient. The GCF is always going to go outside the parentheses, and then the quotient, what I get when I divide both of them by 4, goes on the inside. 4x divided by 4 is x, plus 24 divided by 4 is 6. This is my factored form. If I distributed, I would get back to where I started. We're doing the opposite process. Some more examples. I have 6x plus 36. And again, you can take the 6 and make your factor tree, and your 36 and make the factor tree. And the reminder is you're looking for numbers that occur in both of them, common factors. And once I circle those, to find the GCF, I just multiply them once. 2 times 3 is 6. Again, in this case, 6 goes into 36, so it will be the GCF. We have to find the GCF. Once we do that, we're going to divide each of the terms by it and put the GCF on the outside of the parentheses. Then I do the division. 6x divided by 6 is x. 36 divided by 6 is 6. This is my final answer. Here's another one. 5x to the 4th minus 10x squared. My numbers are 5 and 10. 10 is 2 times 5. 5 is 1 times 5. 5 is the only common factor for the numbers. Look at the variables. A reminder, when I have an x to the 4th and an x squared, the greatest common factor is the variable with the lower of those exponents. So 5x squared is my GCF. I'm going to divide both terms by 5x squared, and put the 5x squared outside the parentheses. Over here, the 5's cancel out, and I have x to the 4th divided by x squared. The rule when we did this earlier in the year is that when you divide x to the a over x to the b, you get x to the a minus b. I subtract those exponents. So 4 minus 2 is x to the 2nd. Minus 10 divided by 5 is 2. X squared divided by x squared cancels out, and I just get 5x squared times, in parentheses, x squared minus 2. In this example, we have only variables. So I look at each variable separately. I'm going to look at the a's. I have an a cubed and an a squared. A squared is the lower exponent. I have b squared and b. B to the 1st is the lower exponent. My GCF is a squared times b. I write that GCF outside the parentheses, and then I look at what I have left. A cubed divided by a squared is a to the 3 minus 2 is a to the 1st. B squared divided by b is b to the 2 minus 1, that's b. Plus a squared divided by a squared cancels. B divided by b cancels. This is not 0. If you take anything and divide it by itself, you get 1. That's my factored form. Here I have numbers and 2 variables. Look at the numbers first. 15 and 5 are both divisible by 5, so that's my GCF. Then I look at the x's. I have x to the 4th and x squared. The least I have is x squared. I have y to the 6th and y cubed. The least y is y cubed. My GCF is 5x squared y cubed. Divide each term by that. This is the work you need to show, that you're dividing each one. And then I'm going to write my answer. The GCF goes on the outside of the parentheses. 15 divided by 5 is 3. X to the 4th over x squared, subtract your exponents. 4 minus 2 is 2. Y to the 6th over y cubed, subtract your exponents. 6 minus 3 is 3. Plus 5 over 5 cancels. X squared over x squared cancels. Y cubed over y cubed cancels. All of this is canceled out. Anything divided by itself is 1. Last examples, now we have 3 terms, and I need to look at all 3. 6x cubed minus 3x squared plus 9. I'm looking for the largest number that divides into 6, 3, and 9. That number is 3. Look at the variables. I have an x cubed, an x squared, and no x. If there's no x in a term, I can put no x's in the GCF. Divide each term by 3. Put the 3 on the outside of the parentheses. 6 divided by 3 is 2. There's nothing to cancel the x cubed, so it stays the same. Minus 3 divided by 3 cancels out. All that's left there is the x squared. Plus 9 divided by 3 is 3. Last example, 8, 4, and 10. 4 does not divide into 8 and 10. The only number that divides into 4, 8, and 10 is 2. Look at the variables. I have an x squared, an x, and no x. If there's no x, I can't have an x in my GCF. Look at the y's. Y, y, y. There's a common y in all of them. Divide each term by 2y. Put the 2y outside the parentheses. 8 divided by 2 is 4. Nothing cancels out the x's. Y divided by y is gone. Plus 4 divided by 2 is 2. Nothing to cancel out the x. The y's are gone. Plus 10 divided by 2 is 5. Y over y cancels. That's the end of my answer. So we need to be able to find the GCF, divide by the GCF, and write the factored form.